I consider myself a comparative biomechanist. And so what that means is I kind of study potentially a bunch of different species or compare how different species function really. And the specific area that I like to research is like motion. So whether that's just like how animals are moving, and kind of like looking at how the environment actually plays a role in how you're moving. So for example, like if this floor is slick, like will you move differently than like if there's good traction on the floor, are good examples. For my research specifically, what I look at is how cane toads hop. So they're the little toads that have kind of gone all over the world at this point, and they're toxic in Australia, like Florida, places like that. And they're really good at landing. So what I look at is like how does surface variation, mainly like springiness, like how stiff or rigid that landing surface is, affects their like landing coordination and ability. One of the main questions I ask is how that surface compliance is really gonna affect how they land and that behavior that they're landing with. So my experiments would kind of look like, I'm having a toad jump off of something that's like rigid and potentially land on something that's either rigid or it could be like springy, like allows for some displacement of that platform. And I'm measuring like the forces, like the impact forces. I can measure like the actual like kinematic or motions of the arms. And from that I can calculate like how much work is being done across each of those joints and see if that's a function of like the surface that they're landing on. So for example, humans like us, right, we might, if we know we're going to land on something solid like concrete, you might choose to land one way, and that might be different than how you'd choose to land on something that's soft like a trampoline that can deform, so you'd probably keep your legs more rigid. So those are the kinds of questions that I ask. Yeah, so again, my experiments kind of just look like I'm hopping toads, usually onto a force plate or something that can measure those impact forces. I'm using high-speed video cameras to actually record where they're moving, especially their joints, through space and time. And I'll usually have a couple cameras set up so that I can actually kind of hone in on where they are in like a 3D space. And then yes, in other experiments, I actually have used EMG or electromyography to measure the actual like activity of the muscles as they're like coordinating those motions. So that's really cool and fun to like kind of compare like how's this muscle turning on and activating relative to like this other condition. I think this research is important and potentially has like broad applications in kind of two areas. So the first, right, is kind of understanding how animals locomote in general and potentially humans. So it could have like health implications for humans, because if we can understand how toads are potentially coordinating their motion, we might be able to understand better how animals in general can kind of have these algorithms that allow them to like overcome certain obstacles in their environment, whether that be like a springy surface or something slick or something like that. And then the second application is potentially for robotics. In my research specifically, the cane toads don't really seem to be affected at all. Like they're not going to land differently on the concrete versus trampoline like you and I would. And so maybe like they still land really well, like robustly. And so like then you could say, well, maybe they're like following some different algorithm or like kind of objective for how they want to land, right? And it could be simpler than ours because in a sense, right, like they're just doing the same thing and it works out for them no matter what. So if we could figure out that algorithm and then program that into a robot, that could potentially save the machine if it's like, needing to decelerate really quickly from like damaging itself.